Today we're going to talk about standard position. So if we have a coordinate system and we place an angle in that coordinate system, we say that that angle is in standard position if and only if the vertex of the angle is at the origin of our coordinate system and the initial ray that we see here in black is along the positive part of the x-axis. So here you see two different angles that are in standard position. This is the red one is the terminal side of an angle that maybe we rotate in the negative direction, and then maybe if we spin this around here we can see an angle in the positive direction. So again, remember we want to think of our angles as rotational angles. So we think of the initial ray starting right here on the positive part of the x-axis, the vertex at the origin. So you hold that point at the origin steady and you sort of flick it, and as you flick it the thing spins around. It's spinning around this way in the counterclockwise way. That's called a positive angle, positive measure. But if we flick it the other way and it spins this way, then the clockwise direction, that's a negative angle. Now notice angles could measure, let's just look at the blue one here. Here we're some positive part here between 0 and pi over 2. These are acute angles. When it reaches pi over 2 right here, it's a right angle. Bigger than pi over 2 here, and it is a obtuse angle. If it reaches right here on the axis, so that we have a straight line, that's a straight angle. And now if we're measuring not where the blue is here, but around here, the measurement spinning all the way from here to here, it's bigger than pi, all the way down here to 3 pi over 2. And if we make it all the way over to where we start again, all the way around one time, that's an angle of 2 pi. But you can also get there more than once. So for example, let's put it right here. That's approximately pi over 4 for that angle. Well, how else could we end up at the same position? Well, we could go by rotating pi over 4, but we could rotate pi over 4 and then another full 2 pi. So it's pi over 4 plus 2 pi. Or we could go this way, which is to go around 2 pi minus pi over 4, which would be 1, 2, 3, 4, 5, 6, 7 pi over 4 negative 7 pi over 4. So there are actually infinitely many angles, rotational angles, that will look the same. So for example, let's do this again. Okay, so we start with the blue one. We could go here, rotate that much, that was pi over 4, and then we could rotate the red one this way, minus 7 pi over 4. They're the same physical angle, the same set of points, but different amounts of rotation. So angles that turn out like this are called coterminal angles. So notice that if you add any multiple of 2 pi radians, or any multiple of 360 degrees, if you're measuring in degrees to the angle, you're going to end up with a coterminal angle. So there are actually infinitely many different angles that are going to give you the same amount. So once you rotate here, you rotate another 2 pi, another 2 pi, another 2 pi. Those larger and larger angles will be bigger and bigger angles, but they will end up at the same place. So in other words, this point here, distance of 1, is tracing out more and more and more of the path as it goes around.